And let me write something here so that my window opens. Okay, now we're back, and we're going to continue with problem number 5. We got locked out of that other screen, so we're going to do it over here. Okay, number 5 covers all of Chapter 4 in one problem. And what you need to do is make a chart. And it talks about college graduates and people who did not graduate, and also men and women. So I'm going to use G to indicate people who graduated, and G with a line over it to indicate people who did not graduate. And then we're going to use M for men and W for women. And when you make a chart, you always have to total in both directions. Okay, so let's see. A committee has 25 members. We're going to ignore that number for now. We don't need it. Including 9 college graduates. So the total for college graduates will be a 9. And then in parentheses it says that 6 are women. So therefore we know right away that 3 must be men. And then it says 16 people who did not graduate from college. So that's the total. And 12 are women, so therefore 4 must be men. And now we're going to total in the other direction, and we're going to get a 7 and an 18, and that adds up to 25. And you also want to check and make sure that it adds up to 25 in the other direction, which it does. The 9 and the 16 add up to 25. Okay, so we have 5 questions with this one chart. The first one says, if the chairperson is randomly selected, find the probability of getting a woman. So that's part A, the probability of getting a woman. The denominator is 25, which we call the grand total. And out of those 25, how many are women? And that is 18. You can leave the answer as a fraction as long as it is a fraction that is reduced, and that one is reduced, so you can leave it like that, or you can change it to a decimal if you want to, which would be 0.720, and I just threw the 0 on there to indicate that if you do have to round, rounding to 3 places is what we usually do. Okay. Part B says, if the chairperson is randomly selected, find the probability of getting a woman who graduated from college. So the denominator again is the grand total of 25, but we don't want all women this time. We want only the women who graduated from college. And so that number is 6. Again, that fraction is completely reduced, or you can change it to a decimal, which would be 0.24. And again, I threw that extra 0 on the end of it. Okay. Part C. I'll do over here. And part C says, if the chairperson is randomly selected, find the probability of getting a woman or a college graduate or someone who graduated from college. So that's a G. The denominator is still going to be 25. There are formulas in the book for OR problems, but I don't like to use the formulas. So for OR problems, I use what is called the circle method. So I'm going to go over and I'm going to circle first all of the women, but I'm not going to circle the total because that would be double counting and you don't want to do that. So I'm going to circle all of the women, and then I'm going to circle all of the college graduates, but again, not the total. So we need every number that's inside the circle. There are several ways to get there. I would probably say that we can see that the women 6 and 12 adds up to 18.
And then you would just have to add in the 3, which would give you 21. Or you could say that 3 and 6 add up to 9, but then you would have to add in the 12, but you'd still get to 21. Or you can just take all of the numbers that are inside a circle, which is 3, 6, and 12, and add all that up and get 21. I do not like the way the book does it, where you add the total for both sides and then you subtract the overlap. But if you want to do it that way, you can. But the bottom line here is that the answer is 21 over 25, and I didn't leave myself a lot of room here, which is also completely reduced. Or if you want to change it, oops, I'm going to say or if you want to change it to a decimal, the answer would be 0.84 or 840. Okay, now part D. And part D says, if the chairperson is randomly selected, find the probability, so we know what P, of getting a college graduate. And then it says, given that, and that's important because that indicates conditional probability. So I'm going to put the line in red. Given that the person selected was a woman. Okay, this is the one problem where the denominator is not going to be 25. I'm going to go back and erase the green circling that I did just a minute ago. Hopefully, that worked pretty well. And then we'll have a nice clean table to work with here. And how's that? That's not bad. Okay, so this time we've been told that we definitely know this person woman. Given that, so it's what comes after the red line, and we know it's definitely a woman. So in conditional probability, you use one row or one column of the table. You don't use the entire table. So because the W comes after the line, we are only going to use the row for the women. I didn't erase the other stuff on the screen as well, but close enough. Okay. So the denominator is not going to be 25. The denominator is going to be 18. And out of those 18, how many graduated from college? Which would be 6. And we finally got a fraction that could be reduced. Whoops. And it can be reduced to 1/3 or 0.333. Okay, and the last part, E. And part E says, if 2 members are needed for a committee, find the probability of getting 2 women.
So we want the probability of women. Okay, we're going to rewrite the question. In the OR questions, you know they're
Or questions because the question has the word or in them.
But this one we're going to rewrite as we want to win the first time and we want a woman the second time. So you got to put the and in there. And you use and if you want 2 of something or 3 of something or something like that. So then on the next line, it's the probability of a woman the first time, add a parentheses, and changes to multiplication. And then times the probability of a woman the second time. And if we look back at part A, it will actually help us with this. When we started, the first question was, what is the probability of a woman? And it was 18 over 25. So that's for the first woman. For the second woman, we assume always that this is without replacement. So there aren't 25 people there anymore. There's only 24. And the one person we picked was a woman. So we know that there are only 17 women left. And to multiply that on your calculator, you do it exactly as it looks. Do not change to decimals and round off, because that will change the answer. Just put in 18 divided by 25 times 17 divided by 24, and the answer comes out to be 0.510. Okay, so moving on to problem 6. That is a probability distribution, and we need to find the mean and the standard deviation. So first, let's copy the table down. The left side is x, and the right side is p of x, and you've got 0, 1, 2, and 3, and the right side is 0.43, 0.24, 0.18, and then 0.15. And to get the mean of a probability distribution, the formula is in the Chapter 5 box. It is the very first formula in the Chapter 5 box. And it says mean, and then in parentheses it says probability distribution. So let's see. Mean of a probability distribution, and its mu is equal to summation bracket x times p of x close bracket. And so the first thing we have to do is create another column called x times p of x. Multiply each x value by the corresponding p of x value.
So 0 times 0.43 is 0. 0 times anything is 0. 1 times 0.24 is 0.24. 2 times 0.18 is 0.36. And then the last one is 3 times 0.15, which is 0.45. So to get the mean, we need to add up that column. And it adds up to 1.05. So we know that the mean is equal to 1.05. Now to do the standard deviation, we have to add, and it'll be 2 more columns, but we'll start with 1 column. And the first column is x squared. So we have to take every x value and square it. So 0 squared is 0, 1 squared is 1,
2 squared is 4, and 3 squared is 9. Okay, and then the very last column that we need is x squared times p of x. And be very careful here, because we are multiplying the x squared times the p of x, not the x squared times the column right next to it. You've got to jump over the one in the middle to get to the p of x. And so the first one is going to be another 0.00. And then it's 1 times 24, which is 0.24. And the next one is 4 times 0.18. It is not 4 times the 36. It's 4 times the 0.18, which comes out to be 0.72. And then the last one is 9 times the 0.15. You've got to jump over the 0.45. And that turns out to be 1.35. And we do need to add that column up as well. And that one adds up to 2.31. Okay, and now we're going to get the standard deviation. I guess the mean was part A, and the standard deviation is part B. So the standard deviation of a probability distribution, sigma, I had to come down a little bit, a little scrunched here, is equal to the square root of summation bracket x squared times p of x close bracket minus mu squared. The summation x squared times p of x means they want the total of the x squared times p of x column. So that is 2.31, and then minus mu squared. Well, we found mu in part A, and that was 1.05 squared. So you multiply and subtract 2.31 minus 1.05 squared. You don't have to show me what 1.05 squared is. And that comes out to be, I'm going to show you the in-between step. You don't have to show me this, but it is the square root of 1.2075, because you don't round anything off in the middle. And it ends up being, I'm going to round to 1 decimal place, 1.1.